In this video, we will talk about testosterone. Testosterone is the sex hormone produced by the male sexual organs, that is, by the testicles. Testosterone production increases in late childhood and early adolescence and remains elevated until approximately the age of 60 and then gradually declines, although much less than estradiol declines in women after menopause. Testosterone plays a very important role in sexual differentiation. In humans, the gametes or reproductive cells that come together to create a new individual are the eggs in women and the spermatozoa in men. They have 23 chromosomes, and one of these chromosomes is the sex chromosome, which is always X in women and may be X or Y in men. Somatic or non-reproductive cells, that is, all cells except eggs and sperm, contain 23 pairs of chromosomes, and one of these pairs of chromosomes are the sex chromosomes, which are always XX in females and XY in males. When two gametes join to generate a new individual, the egg always contains an X sex chromosome, while the sperm cell can contain an X sex chromosome that will give rise to a female, or a Y sex chromosome that will give rise to a man. At 6 weeks of gestation, sexual differentiation has not yet begun, so the embryo is identical in women and men and consists of gonads and two ducts, the Wolff's and Mueller's duct. At 10 weeks, sexual differentiation begins, that is, feminization and masculinization. Embryos that have the Y chromosome begin to express genes and synthesize proteins encoded on this chromosome, which have an effect on the development of the reproductive system, inducing the differentiation of the gonads into testicles. The testicles produce anti-Mullerian hormone that blocks the development of the Mullerian duct, and testosterone that stimulates the maturation of the Wolffian duct and later the development of the male reproductive system. Feminization is produced by the absence of the Y chromosome and of the proteins encoded on this chromosome. In the absence of these proteins, the gonads do not mature into testicles but into ovaries. In the absence of testosterone production, the Wolffian duct atrophies, and in the absence of anti-Mullerian hormone production, the Mullerian duct can mature and end up differentiating into the female reproductive system. The difference in the length of the index and ring fingers of the hand is an indicator of the prenatal levels of testosterone to which the fetus was exposed. The index finger may be shorter than the ring finger, the same length, or it can be longer. Normally, in men, the ring finger is longer than the index finger, while in women, the index finger is equal to or longer than the ring finger, and this is related to the amount of testosterone during fetal development. In the fingers of men and women, there are testosterone and estrogen receptors, and in both sexes, the number of receptors is higher in the ring finger than in the index finger. When testosterone binds to the testosterone receptors present in the fingers, growth is stimulated. Whereas when estrogens bind to the estrogen receptors that are present in the fingers, growth is inhibited. In men during fetal development, there is more testosterone than estrogen, while in women the opposite occurs, there is more estrogen than testosterone. Consequently, in men the finger with the most receptors grows more due to the effect of testosterone, while in women the finger with the most receptors grows less due to the inhibitory effect of estrogen. There are people in whom this indicator does not coincide with gender. That is, there are men in whom the index finger is longer than or equal to the ring finger, and women in whom the ring finger is longer than the index finger. In these people, it is considered that the amount of sex hormones during fetal development could have been altered, and this alteration has been associated with fertility problems, with sexual orientation, and with sexually biased diseases like autism. In men affected by multiple sclerosis, it has also been seen that the ratio between the size of the index finger and the ring finger is greater than in healthy men. That means that in men affected by multiple sclerosis, the ring finger is usually shorter than the index finger, which suggests a lower prenatal exposure to testosterone and therefore a possible protective role of testosterone for the development of multiple sclerosis. However, testosterone production in these men did not show significant differences. The prevalence of multiple sclerosis in adults under 50 years of age is lower in men than in women, while there are no differences between the sexes in childhood or after 50 years of age. More testosterone is produced in adult men younger than 50 years than in boys or men older than 50 years, suggesting a possible protective role of testosterone in multiple sclerosis. And supporting this idea, it is important to point out that in men affected by MS, a frequency of hypogonadism or hypofunction of the testicles is higher than in healthy controls. Although we do not know yet the exact mechanism by which testosterone could protect against the development of multiple sclerosis, it is believed that it could do so by influencing both the immune system and the gut microbiota. It is believed that testosterone can act on the immune system, favoring the development of anti-inflammatory responses. Testosterone also appears to have an effect on the gut microbiota. In mice predisposed to autoimmunity, and in particular to type 1 diabetes, it has been observed that before puberty, that is, before sex hormones are produced, the gut microbiota in males and females is very similar. In contrast, after puberty, when sex hormones are produced, the microbiota in males and females is very different. The one of females does not vary much from the one which existed before puberty, but that of males changes significantly, which suggests that testosterone has a very important effect on gut microbiota. And in fact, if male mice are castrated and therefore do not produce testosterone, the microbiota that develops in these mice is very similar to that of females. When these mice grow up in a normal environment where bacteria are present, the incidence of autoimmunity is much higher in females than in males, suggesting that the bacteria that males have in their gut microbiota could be protective. If these mice are grown in a pathogen-free environment and given a specific composition of bacteria to repopulate the identical gut microbiota in males and females, the development of autoimmunity is comparable in both sexes. Whereas if some of the male-only bacteria are transferred to males under normal conditions, the prevalence of autoimmunity is once again lower in males than in females, supporting the idea that testosterone promotes the development of protective bacteria and that they probably facilitate the activation and development of regulatory immune cells. The progression rate of multiple sclerosis in adults under 50 years of age is greater in men than in women, but there are no gender differences when the disease begins in women after 50 years of age. Women from the age of 50 produce estrone, which could be related to the increase in progression in women of this age. However, men also progress and do not produce estrone. And something similar happens with testosterone. Men under 50 produce testosterone unlike women under 50, so one might think that testosterone could be related to progression in men. However, when the disease begins in women older than 50 years, they show disease progression comparable to that of men without producing testosterone. In addition, it has been seen that low testosterone levels correlate with greater disability, which supports a protective and non-pathogenic role of testosterone. Based on everything discussed so far, it seems logical to think that increasing testosterone could be a very interesting strategy to treat multiple sclerosis. Testosterone can be increased by administering exogenous testosterone. However, due to its adverse effects, among which are infertility due to testicular atrophy, as well as the possibility of an increased risk of prostate cancer, cardiovascular problems, heart attack, or stroke, the administration of exogenous testosterone is not advisable. A safer and more recommendable strategy is to increase the production of endogenous testosterone through healthy habits such as a healthy Mediterranean diet, reduction of the level of stress, increase of aerobic physical exercise, or sleep more hours. Obesity, for example, is associated with very low testosterone levels.